Hello and welcome. We're really excited to have everyone here today for our weekly OCI deep dive. I'm Zaid, Product Marketing Manager with OCI Go-to-Market Strategy Team. And today we're joined by my colleagues, our presenters, Renato, Jan, and Jost. They're all principal product managers and part of the Oracle Servers product management team. We also have VJ, Senior Principal Product Manager with Oracle Servers PM team as well. VJ will be helping us with the Q&A. Together, they'll walk us through a very interesting topic, and that is OCI Secure Desktops Service, known to many of you as Virtual Desktop Infrastructure. How to activate it within your tenancy, and how easy it is to use a web-based client to access desktops. OCI Secure Desktops is completely integrated with OCI Compute, Storage, and Networking Services. That's enough for me now. Please go ahead and take it away, Renato.
All right. Thank you, Zaid. Thank you for the introduction. And welcome, everyone. Thank you for taking the time today to watch our presentation. Thank you for answering the questions, too. My name is Renato Ribeiro, and together with my colleagues here, we manage the Oracle Cloud Infrastructure Secure Desktops Service. So I'm going to provide you an introduction on the features of this service. Joost is going to also talk about one of the key use cases that we've seen for the service. And we want to reserve enough time for Jan Mangold, who is going to provide you a demo of the service, not only on the user side, but also on the administrator side. So with that, let's start. So we all know that many of us work with mobile devices. We work on environments that are flexible, and we have our mobile devices in public places. And we all know that devices that are in these places they present a risk of being compromised or being stolen. So it's a reality of flexible working that data that is in mobile devices can be compromised. And we have more and more companies and employees taking advantage of flexible work environments to increase their efficiency and so on. Now, that creates a challenge for IT in terms of securing, managing these mobile devices that are in the employees' hands. And well, the biggest challenge there is security with the data and the applications that are running in those devices. Now, making those devices more secure and making them more manageable is one of the purposes of virtual desktop infrastructure. That is a technology that can help increasing the security of these mobile devices, increasing the security of your access to your companies, on your organization's data and applications. And not only we're talking about the security of the data and applications, but we're talking about the fact that once you have applications running on your device, you have to go through several steps in terms of securing your network and making sure that you have, for instance, bastions for setting up your access, etc. And having your desktop running inside cloud close to the data and applications can actually simplify your access, your secure access, to the applications and data. So some top use cases for virtual desktop infrastructure, or VDI, as I was saying, is when you have a distributed and remote workforce where you have a security issue with devices that are in the hands of employees or people that are collaborating in your company, in your organization, and you want to make sure that those are secure. Another interesting case is for task workers. For instance, nurses in a hospital or doctors in an office. Those task workers typically need to have access to their desktop, and they actually their work is facilitated when they can take their desktop with them, connect to one device, and then move to another device, and be able to carry their state or their desktop from one machine to the other on a secure way, because they will be dealing with confidential data, etc. So when task workers have, for instance, shifts where they're working with their desktops and need to move from one station to another station, VDI will help with that process. Another interesting case is call centers. Let's say that you have shifts where you have employees that will work a shift in front of desktop, and then as their shift ends, another one starts, and you have another employee looking at that device, but they can access their virtual desktop from that same local device. So every time you have someone that needs to bring their desktop up on a system that is not particularly theirs, it's a use for virtual desktop infrastructure. Another interesting case is when you want somebody to access your applications and data through their own device. So if they're bringing their own devices, be it if they're contractors work in your organization, or if they're students that are coming to your university, VDI allows these devices to access application and data in a secure way. In a matter of minutes or hours, someone that is just connecting to the organization can have a desktop ready for them to work with you, and then when they're done, you can simply destroy those desktops, and the devices that are brought in to connect, they don't have any state. So it's a great way for you to have somebody that is going to collaborate for a few weeks or a few months or a few days with your company or university. Another use is when for instance, you're a developer and you have your local device, but you actually need more powerful devices or more powerful compute to work on applications or to test the applications or to run high performance computing. So you actually can have a developer or an engineer with a device that is light, and then that light device can connect to a compute VM that is much more powerful to be running calculations or to be doing development work. So these are some of the use cases that are used, or where virtual desktop infrastructure can help, and this is where our service comes in, because our service, Oracle Secure Desktops, is an implementation of virtual desktop infrastructure inside Oracle Cloud Infrastructure. You can instantaneously provide Linux or Windows desktop environments to workers anywhere in the globe. You can rapidly enable access for temporary workers, for instance, to corporate systems and secure data. And because the service is located in the edge, you don't need a VPN to be able to access the service. You benefit from all the continuous update in terms of security and hardening that happens in Oracle Cloud Infrastructure, and the centralized management of these resources. The fact that you can, with simple commands, create a pool of virtual desktops that are assigned to a group of users, make this very easy to manage and very effective. Now, the way you create and manage these virtual desktops is through the use of your Oracle Cloud Infrastructure tenancy. If you have a tenancy today where you're using compute service and creating VM shapes, or if you're using block storage and you have set up your virtual compute network, if you're using OCI networking services, all those are leveraged by the secure desktop service. So the desktops are running in VM in the compute service, using storage for the boot device and to keep your files, and using networking, of course, to access it. So all those are the standard services available in OCI that you're going to leverage on the secure desktop service. And the secure desktop service will present the desktops running on the compute VM to remote client systems, to your laptop or desktop in front of you. But the only thing that is shown are the pixels from the screen. You don't have data that is moving to the device, to the user device. You simply have the pixels of or the screens from the desktop that are shown. And all the management of creating pools and managing the desktops is done through the Oracle Cloud Infrastructure, or the Oracle Cloud Infrastructure Console, I wanted to say. So this is a diagram of how the service works. At the bottom here, we have the traditional desktop use, where you have a device that has state. You have a device, a laptop or a desktop that has company data, has company applications. An end user authenticates into that device, and then that device, through the authentication, can access applications with Oracle Cloud or on your on-premise data center. But the fact is that that device has to be secure. Typically, the data has to be encrypted and so on. But that is the security risk that you have, because you have local data and that device with state. And also you have the complexity of managing that device that is remote. And then you have all the other restrictions about the fact that the only compute that you have access is the compute inside that device in front of you. On the top here of this slide, you have how Oracle Secure Desktop's service works. The desktop is running into a VM shape inside Oracle Cloud Infrastructure. You can choose the size or the type of that VM shape. You can have a lighter one or a more or one with more capacity. And that virtual desktop running Oracle Linux or Windows will connect or run the applications, connect to your data, be it on OCI or on your data center. Now, once the end user connects to a certain device, which can be their own device, or it can be the company device, or it can be just a temporary device, that device doesn't have to hold any data, no applications, because through the authentication of Oracle Cloud Infrastructure, the user basically will only see the pixels or the screen that is coming from the virtual desktop that is running inside OCI. All the applications and all the data running inside OCI, the only thing that is being presented to the user is the screen of the desktop. And we're going to see on the demo soon how that works. Now, we believe that the most value out of the service is achieved when you have all your applications and all your data inside Oracle Cloud Infrastructure, and then you can take all the benefits of having your data secure inside OCI. You can have all your applications running inside OCI. So the benefits of using a service like Oracle Cloud Infrastructure Secure Desktops is that we basically provide you a desktop as a service feature. You can create pools of desktops and then assign those desktops to users. And the users just need to have access to Oracle Cloud Infrastructure to be able to see the desktops that are assigned to them. You can create pools. You can increase the number of pools. You can also decrease the number of pools. So you can, for instance, create 100 desktops for training for about a month, and then just do away with it after that. So you have the elasticity of create more and control the number of desktops assigned to the users that you want to have desktops assigned to. And that is done through centralized management. It's a very simple interface with basically one screen. You can create desktop pools for the users that you have once you have prepared the environment and have set your user groups and images for desktops, etc. So this is a native VDI solution inside OCI, which will leverage all this integrated security on your compute, on your storage, on your networking, and on the security that was created to enable this service to be presented to you. And then all the cost efficiency of be able to manage centrally these devices and the other features that we have for scheduling, the start and termination of pools. This is a little bit more detail how the service works. On the right-hand side, you have the customer tenancy. On this tenancy, you're going to run desktops inside compute shapes in your tenancy, and then you're going to access storage for boot devices or for user files. So inside your VCN, you'll be able to access, run your VM shapes with storage, and then you can connect to other services and other other services or other applications inside your tenancy. So, for instance, you can have your application and your data running on your tenancy and have your virtual desktops accessing that. Now, the desktop, the service itself, the secure desktop service, has a control layer and a device layer. The control layer is responsible for creating the desktops, managing access to those desktops, controlling the users that are going to see desktops, doing all the setup of them, etc. The device layer is responsible for taking the screens or the pixels from those desktops and assigning them or presenting them to the users that own those desktops. So you see on the left that you can see your desktops either through a native binary or an install client or a web browser. So typically, if you have you have your own device or you're using that device every day, you typically have an install client to see your virtual desktop. If you have a borrowed machine or you just use your desktop, on a not on a regular basis, you could use a web browser to access your desktop and provide you more flexibility about the hosts or the machines that can see your desktop. Right? So a couple more words about how secure desktop service works. The end users find their desktops through a web application. Basically, each region in OCI has an access URL. Once the user authenticates into OCI, he or she will be presented with the desktops that is assigned to them. And the service, as I said, is on the edge, so there's no VPN required. So the users are entitled to a desktop in a pool via, through their IDCS group membership. So the administrator will associate those users in that group to the pools that are going to be managed, and there will be policies, controlling that, just as you would control policies or access to services inside OCI. And users then interact with that virtual desktop through an installed or a web client. Now, important to notice that the desktops are persistent and follow the user. So once the user is assigned a desktop, they can access it from any location. They can switch between the clients, install client or web client. They can stop using on this machine and then start using it in another machine and so on. But the desktops follow the user. And all the data remains in the cloud. Full control over the network connectivity goes through the OCI administrator, etc. And over the device access policy, which means that all the applications, the data are going through the service and through the controlled access into the screens or the local machines. Now, all the desktops are created on demand and they're in their compute instances in their tenancy, their VM shapes inside your tenancy. So once you create your pool, as users get into the pool and start using and taking their desktops, that's when the desktop's going to be created by taking compute shapes, taking storage, and taking networking resources. And once you start using OCI compute, storage, and networking, the standard charges for OCI services happen. Now, there's a charge for the OCI Secure Desktop service because there's a charge for the service that's going to organize the desktops, going to create the pools, they're going to set up the pools, install them, and then make sure that users can access them. That charge is per desktop per month, and with a minimum of 10 desktops per pool. Now, that charge is $5 per desktop per month in the US, and you should check the OCI cost estimator for more details in your region. So the charges are per month, but they're actually metered on an hourly basis. So if you create a desktop and then destroy it, you'll be charged for the amount of hours that you used that desktop. Now, the pools and configurations are created in the OCI console, and you have to choose the OS image and the compute shape for the desktops. In the pool, all the desktops will have the same shape and they will have the same OS image. So in that sense, all the desktops are in the pool are identical, at least when you create them. And then you can take advantage of all the networking inside OCI to access applications of data that reside inside OCI. So that way, you can have very short latencies between your desktop and the application and the data. And only the latency that you have is for the demonstration or the presentation of the screen from the desktop. Right? So with that, I'm going to turn it over to Joost, who's going to talk about one interesting use case that we've seen with customers.
Okay, thank you, Renato. Usually people think around VDI, essentially you're sharing desktops just to share the desktop, to have that as a work environment, as a regular desk environment. However, one of the things that we've seen a lot of usage in, and is a very interesting use case, especially in context of other OCI services, is that we see customers trying to connect to the back end of some of their services running in OCI. So the OCI will have front-end services that you can connect to or get data from, but quite often there's also development that's happening on the back end, working with, for example, database services or like in the picture here, Kubernetes. So what they often do is they set up a Bastion server and then SSH through. That's all nice, but the tunnel that you're creating essentially is opening a tunnel to the outside. That's one. Two, some of the data that might actually be residing in OCI might come out in form of caches or things that you've stored locally. But third, it's quite fragile, and it's very hard to actually tunnel certain things through that might actually need to talk to a certain port on one of the services inside. So what you then do is you set up an SSH tunnel and or multiple SSH tunnels, and then all through the Bastion server, and hoping that it'll all work. One of our customers had the term guacamole for this. So as a counter to this, what we're seeing is customers looking at the Secure Desktops product as a way to essentially create a local environment inside OCI that you can just access from anywhere. And it can actually directly talk to all of the services. It won't have any restrictions with regards to ports. You don't have to tunnel anything. You can essentially create an environment that is working right in the middle of your OCI environment. Could even be put on the same VCN or subnet if you want to, and can thereby also be very restricted in what it can actually see outward. You could actually make these environments in such a way that they can't even talk to the outside world if you want to, or only single direction. People might be putting them together with their Git repository or other types of things that they're using to kind of cooperate, so you can actually have a group of people cooperating together. So this is sort of what you see in the picture here, is we see customers using on-premise desktops or laptops that might actually be behind, in their WAN environment, but also maybe even on the road, connecting in securely through secure desktops into essentially a work quote unquote laptop that is connected through to whatever service they need to connect to. And this could be that they connected only to one. A certain group of people might only be able to access one set of databases or things like that. Another group might be seeing all of them, or other subset. So you can also segregate things out the way that you want to by putting different pools into different VCNs or subnets and have rules around this. Next slide, please. So the use case is really where customers connect from anywhere to their development desktops. So the development desktop is running there in OCI. It can actually run very close to the OCI services. One of the people in the Q&A said, you might actually want to have a desktop as a service for very latency-driven client-server FAT applications. This is actually another reason to maybe do this, right? So it's a very similar thing. I might actually have an environment that needs to be very close to my my database because it's very latency sensitive, and I want to have it run right next door. So it's running next door. It actually could be connecting to the same tools. There might actually be dedicated tools in those desktops that you might actually not want to be able to or need to install on your laptop or other device that you might be using to connect in. You might actually want to have very specialized or things that have specific access keys or things like that only available in this desktop. You might want to use data visualization or compliance tools to test things internally in such a way that they don't get exposed outside. And you can, of course, preload them with anything you want. And the nicest thing really about all of this is you can actually choose any shape. So it could be that you have a traveling laptop that's actually quite lightweight, could even be something like a Chromebook or something like that. And then you connect in, and what you get on the back end is something very fat. So one of the customers that we've had today actually had a very, very, very large, I would not even call it a desktop, use case where they're running a very large client that's connecting to databases and testing things out or showcasing how this would look. And they are using these very enormous desktops, but the clients connecting in could be essentially nearly everything. So the benefits: highly secure, nothing ever leaves the OCI. So therefore, if you have very strict compliance regulation type of things, you can easily meet those with this. Even if you're doing the development on the complete backend, it's very easy to integrate in the regular DevOps flow that's already in OCI. We have many services that allow you to create a nice DevOps flow, and in this way you can sort of create like a complete environment. You can easily clone off new environments, so it's easy to onboard new developers. Say, okay, they're going to get a new desktop, they get everything is ready, they don't have to install anything, it's all ready to go. And it's very easy to kind of have people work from many different organizations in different parts of the planet, even connecting in and work on a single network. So as I said, we have a bunch of customers running this. So as you can read in the quote below, we have one of our customers really, really happy with this, and they're sort of quickly growing their footprint. It's really a very different way of looking at how to develop OCI services in OCI. And with that, I'll hand it back to, or actually I'll hand it on to Jan.
Yeah, hi, good morning. I'm going to share my screen and show you a quick demo of our service. And I will start with the end user view of the service. The end user basically goes to a particular URL that is region specific, because the compute instances that actually provide the desktop are in a particular region. So when a user goes to the URL, they have to sign in to the tenancy, your tenancy, where the desktops are actually provisioned. And this happens through the simple UI that you know already when you sign into OCI. Since this is an OCI native service, we integrate with IDCS, the identity management system in OCI. So you have the ability to, for example, have different identity domains, which you then just choose to sign in. And I'm just going to sign in as myself, of course. This is interesting. Not hands. There we go. And then the end user is being presented with a very simple user interface that shows all the assigned desktops, which means the assigned pools. And as Bernardo already mentioned, the assignment happens through group membership in an IDCS group, and a policy that basically says that the members of that group are entitled to use a desktop in that pool. And as you can see, you can be member of many pools. Currently, since I'm an administrator, I see all the pools. A user can only have one desktop per pool, but can obviously be member of several different pools and thus have access to more than just one desktop. By default, all desktops will be launched in the web client. You can go to the preferences and basically switch between the web client or the installed client, and you can download the installable client also from this simple web interface. I already have installed the client, of course. If I look at this, I can see that these two pools I already connected to. That's why they say available. Whereas the other pools, there would be a new desktop. I have never connected to them. Therefore, once I connect to them, a desktop in that pool would be assigned to me. And the important part is once you connect to a pool, if you're entitled to, and if there are resources, you will always return back, to the same desktop. So I'm in the web client right now. I just click on the Linux pool and it will now connect me into the desktop that I connected to before. And since it is running in OCI, it is persistent. And what you will see, or what you are seeing, is exactly what I saw before, 10 minutes before the meeting when I connected in. And when I disconnect, everything keeps running in OCI. So you can either change location, or you can change clients, or even location. I'm going to show you the same thing with Windows now. Currently, we support Windows 10 and 11, but you have to bring your own license for those for now. But it completely works. You see, I just updated Windows here, and this is the web client. And now I'm just simply changing to the installed client here. I'm going to launch the desktop again, and what you will see is that this particular connection is going to be terminated because I'm connecting to it again now with the installed client. And the same would happen if you actually went from home to the office and connected to your desktop. It would basically just follow you, and the previous connection would be terminated. Here is the connection now for Windows. Right. The important part here is that only one connection to the desktop can happen at any given time, which is why the desktop is going to follow you when you go from location to location, or you change the end device and connect again to your desktop. Obviously, you can resize everything. And the remote desktop will accordingly resize as well. The same goes for the Linux desktop, but I don't think I need to show you that right now. Another thing is that when a user interacts with this, everything goes through HTTPS, so all the traffic is basically encrypted. We do not expose any native protocols to the internet. We have our own protocol that gets tunneled through HTTPS or SSL encrypted. There are no other ports that need to be opened. So as with the use case that Joost mentioned, the nice thing is that you don't need to do any tunneling magic to get to particular ports of particular services, because your desktop is basically being provisioned in a network that is completely under your control, and you can then open ports to particular services in OCI, for example, or even external services or services on premise. Because since this is running in your tenancy and you control the networking these desktops are actually provisioned in, you have full control. The end user can only interact with the pixels, as Renato said. And another benefit here is that since we control how the pixels are transferred to the end user, we also have the ability to say whether the end user can actually copy and paste. So you have full control over that as well as access to audio devices, or, for example, if you want users to be able to connect to locally attached storage. So, for example, I'm on a Macintosh connected to a Windows operating system, but I still have the ability to access the files that are on my local system. So in my case, I have two different access points here. I have my home directory and I have my temp directory. So when I access the temp directory, I can now copy files from my local system to the remote desktop and vice versa. And that also is completely under your control. You can basically switch this off completely, or you can turn it on read-write or read-only. So for certain users, for example, people who need to upload patches or something like that, you might want to enable this feature so that they can copy a patch that they have on their local system to the cloud environment. Now that we have looked at how this is presented to the end user, let's look at the small screen. Let's look at how this is presented inside the OCI console. So when I go into OCI console, I'm already logged in and I'm already in the same region that I just accessed the desktop from. The service will be found under compute and it's called secure desktops. And we have the desktop pools and desktop volumes, and I will talk about the desktop volumes in a second. So when I go to desktop pools, I will see all the pools that have been created in a particular compartment. Compartments basically in OCI, for those of you who are not familiar with that, are like a directory structure that allow you to actually compartmentalize services, be it compute or anything that is being offered in OCI as a service, lives in a compartment. There's a root compartment, and under the root compartment are a cascade of other compartments. Like if I look at this, you can see we have many different compartments and we name them in a way that makes it easy for us to determine what actually is in that compartment. And when I look at a particular pool, I connected to the Linux Sanity pool before, you basically see how the pool is configured, which availability domain, what is the device access policy, what is the image and shape, and so forth. And you can see which users actually have been assigned to a desktop that has been provisioned in this particular pool. And from this interface, you can also control whether you want to delete a particular desktop, start and stop a desktop, or possibly see any errors that occurred with that desktop. Scroll back. You can also edit a pool. There are certain things that you cannot edit, which is the shape and image and network configuration. But other things you can edit at any time. For example, the maximum size, which is like a high watermark, which means like this particular pool can add a maximum provision 25 desktops. And currently, I think it only has provision 13. So the next user that would come in would basically provision another desktop for that user. And in order to speed it up, you can also basically say that you want a desktop to be provisioned so that when the next user comes in, that they can immediately be assigned to that pre-provisioned desktop. And the standby size you can also control and change at any given point in time. And as you can already see, you can always change the device access policy. Currently, everything is enabled. So if you basically wanted to disable the drive mapping, you can just go in and switch it to none or read-only, for example. Another interesting fact is that you can actually attach a schedule to your pool, which means that you can say, start all the desktops at 7 in the morning, Monday through Friday. So now all desktops will be started Monday through Friday, 7 a.m. in the morning. And let's say at 8:45 Monday through Friday, we want to shut down those desktops, which means they don't run overnight or over the weekend, which helps you save cost. It's equally easy to actually create a pool of desktops. So you just go into a particular compartment and you say create desktop pool, give it a name which is visible to the end user in the web UI, so they can identify which pool they actually connect to. And this is just a free text string. You can put anything in here, right? You can also assign a description, which is only visible to the pool administrators. Optionally, you can assign a time when you want that pool to be created. And at the same time, you can also say when you want the pool to be stopped. So this can be used for trainings or trade shows or something like this. So you can actually create a pool ahead of time and also schedule when the pool should be stopped so people can no longer access it. Important here is that it will only be stopped, meaning that all the desktops in the pool will be stopped and it won't be available to end users anymore. But you still have to delete that pool if you so choose. Since we, Oracle, have no access to the actual OS that is running inside the desktops, if a user has any problems with it, you need to actually provide how the user can get help when they have problems, the end user that is, and you put in any type of information, email address, phone number, website, or whatnot, which is then being presented to the end user through the help interface. Oops, somebody put something in here. So as you can see, it's just text that the end user will see how to get help for their desktop. When we provision the desktop, which is the OS image that you provide on the shape that you choose, we actually by default create a common user called desktop user with a randomized password that is different for every single desktop and not even known to the end user, which means when an end user connects to their desktop, they are not even being asked for a password. They're just being dropped into that desktop on their personal compute instance with that generic user called desktop user. And when you use that default, you can even determine whether you want that user to be an administrator or have administrator privileges on their desktop, which means sudo privileges on Linux or being in the administrators group on Windows. Or you can choose not to do that, which means if the user wants to install anything that requires administrative privileges, they would actually have to ask for help because they can't do it themselves. Now, you can also tell the service to not create default user, in which case you would need to integrate your operating system that you provision for the desktop, Linux or Windows, either with LDAP or Active Directory. And then the user will always be asked for the credentials to log in, the username and password. Next, you basically define the maximum size. The minimum is 10. You can change this value at any time, even after pool creation. This is what the service is going to be charged by, meaning in this case, it would be $5 per month per desktop, so $500 per month. Did I do my math right? You can change this number anytime. You can increase it and decrease it. As Renard already said, it's metered hourly, so the $5 per month are going to be prorated. The only caveat here is that once you have provisioned desktops in this pool, you can only decrease the number to the number of already provisioned desktops. So once you have like 50 desktops running, you cannot go in and change the maximum size to 10, for example. And the standby size is, as I mentioned, the pre-provisioned desktop. For example, a Linux desktop gets provisioned in like under 2 minutes. Whereas when you provide a Windows 10 or Windows 11 image, which preferably should be sysprepped, when the image actually boots up, it reboots at least once to get out of the sysprep state, and that we have seen can take up to 15 minutes, which means even though desktops are being provisioned on demand, when a user connects to their desktop for the very first time and it needs to spin up the image, in the case of Windows, the user would sit there and wait for 15 minutes until the image is finally ready, or the instance is finally ready. And for that very use case, we basically implemented the standby size. This is optional. You can set this to 0, which means there are never going to be any pre-provisioned systems. And you can also change it after the fact by editing the pool. So let's say you create a new pool, you tell your users about it, they come in, you have a certain number of pre-provisioned instances so that the users coming in can connect to their new desktop immediately. And once the first wave of users has come in, you can decrease the standby size or even set it to 0, which means there are no pre-provisioned systems available, and any straggler that comes in a week later or something, they would just have to wait until it's being provisioned. For the regions that offer availability domains, you can choose which availability domain you want to provision all the desktops in. As Renato already said, a pool means that everything in that pool is homogeneous, which means everything is in the same availability domain, has the same image and shape, and all the other pool attributes that you can define here. Now, what happens when you create a pool is you basically say, let's use a particular image in a particular compartment, and the image is basically just a compute custom image. So as you can see, we have several different images here. So if I choose this image, it basically shows me which shape the image actually supports. And that shape then shows up in this drop-down window. When I choose a different image, they look the same because we basically want to test all the different shapes, but you have full control over the shape that the desktops are provisioned in, and you also can control which of the shapes should be offered, right? Currently, we only support x86-based shapes. In the future, we'll also support our ARM offering in OCI, very near future. But the reason that you, for example, don't see any bare metal shape in here is this one. This image basically is configured and has not disabled the bare metal shapes. So if I were to create a pool with this image and this shape, every single desktop right now would actually be provisioned on a bare metal standard instance, which would be cost prohibitive, really. But this is completely under your control. We do not limit the shapes that you can provision on, except that they need to be x86 shapes. And you have full control over the image, meaning you create a golden image that you want to be provisioned for the service. And our service basically just provisions the desktops in a fire and forget fashion, even associated with the schedule, so that you don't have to worry about users coming in needing a desktop. Since the image or the desktops are, when they're provisioned, the OS basically just sits on the boot disk, right? When a user logs in, all the data the user creates are also on the boot disk, which means, particularly when you use our default desktop user, which means if for whatever reason something goes wrong with the instance, you need to delete the instance, or the user needs to move to a different kind of desktop, different pool, they would lose all the data. So for that reason, we also have the option to create an additional storage volume that is assigned to the user independently of the desktop, which means if I have to delete or move the desktop, the user's data on this particular storage will survive. And if the storage exists and the user connects to a different pool, maybe that also have storage enabled, the service will all automatically remount the existing storage if it exists, so the user can retain their data. And this is completely up to you. You can switch this off or on as you wish. As already mentioned, you have complete control over the networking, which is you have a VCN that you need to create, of course, in a particular compartment. We keep everything in one compartment so we can share it. So there are different VCNs that live in this particular compartment, and each VCN has a subnet. Obviously, you control the size of the subnet. The only thing that you need to be aware of that you cannot provision more desktops than IP addresses available in the subnet. So if you have a Class C subnet, obviously that limits you to 252 desktops, because we also need at least one IP address in that subnet so that our service can actually create a private gateway into your subnet to access the desktops in that subnet, which means that all egress and ingress to the desktop happens through our service, which also means that you don't have to pay extra, or the billing structure doesn't change whether you use the desktop 1 hour or 24 hours a day. It always stays constant because all that traffic goes through our service that you already pay for with the $5 per month per desktop that is being charged to the size, the maximum size of the pool. Since you control the VCN, you also control what access the desktop has inside Oracle Network and outside of Oracle Network. So all desktops basically just have a private IP address, which means they're limited to the subnet that they're in. And if you want to provide internet access, for example, you just create a NAT gateway in OCI and assign it to that subnet, and then users can actually go out to the internet. And then you can also either provide NSGs, network security groups, that you can assign to a pool that will then be assigned to every single desktop in that pool, or you can use security groups in the VCN that are assigned to the subnet to control where users actually have the ability to establish network connections to. So all the granularity that OCI provides in this particular segment are available to you and under your control. All our service does is to use the image that you provide the service and the shape that you choose with the network, and then it provisions the desktops for you, all through a single simple interface here, and you don't have to worry about the rest anymore. As already mentioned, device access policy and regular schedule. And once you have filled everything out, you can also have optional tags associated with the pool, which means anything that you tag the pool with, every instance in that pool will also be tagged with, which can be used for all different sorts of things, because those tags can be queried from within the image. Therefore, you could create some type of automation based on the values of the tags that you choose. And then you just hit create, and the pool is being created. And last but not least, I want to show you, for example, this was, where's mine? So here is the instance that I am connected to, and I can just copy the OCID of the compute instance and put it here. And now you can see the actual compute instance, because all our service does, being OCI native, using the other OCI services, it basically just creates a compute instance for you dynamically. So everything that you can do with compute instances, you can also do with a desktop instance. For example, creating a console connection to it and so forth, and all the other stuff. And here you can also see that it doesn't have a public IP address, only the private IP address, which means the only way to access those desktops running in any compartment that have been provisioned through our service can only be accessed through our service, since they don't have a public IP address. So you can't just SSH into those or RDP into them from the open internet, because it's just not available. If you do want other access, you could access them from within the same subnet if you have credentials or SSH keys embedded in your golden image through a different instance that runs in the same subnet, or in a different subnet with the correct routing enabled. But that's just basic networking. So the only other thing I quickly wanted to show you is when I go to compute custom images. Here we have all our images in the shared desktops resources compartment. Click on the one. And here is this pink image that I used earlier. And here you see the compatible shapes. And you just simply go into the details of that image and say, I don't want to use the bare metal shapes. And then you save it, and this particular shape now will no longer be offered when you provision this image for a pool, for example. Again, all of this is completely under your control. So we don't prohibit anything. The only thing that we limit right now is the architecture. So it needs to be x86, as already mentioned. And for networking reasons, we actually create our own NSG for a pool, so that our service can connect into not only your subnet that you provision the desktops in, but also the individual desktops. We need a network connection to them. And that pretty much concludes the demo for...
Thank you, Jan.
Yeah.
Thank you, Jan.
Good.
And I'll go back to the slides then. And for the interest of time, I'll probably be going through these fast because I just want to make a few points. As Jan was saying, that there's some work to be done to prepare your tendency to create then secure desktops. So you have to set up user groups and policies for the service, of course, create VCNs, subnets, etc. And you have to prepare images so that you can create your desktops either with Oracle Linux or with Windows. Now, we created a ORM stack to simplify the first-time setup of a tenancy for OSD. And an ORM stack, it basically utilizes OCI Resource Manager to automatically create resources in a tenancy. So for all these steps in terms of setting up policies and create VCNs and important custom images, you can use your ORM stack to automate and simplify these tasks when you are preparing your tenancy for the creation of secure desktops. So I encourage you, once you decide that you're going to be using the service, to use the ORM stack as a way to facilitate or ease your setup of your tenancy, and then start creating your pools. Some frequently asked questions. Today we support Oracle Linux 7 and 8 and support Windows 10 and 11 desktops. We are going to expand that in the future with other operating systems, especially on the Linux side. So we're looking at in a future date supporting Linux 9. As I mentioned, the cost for the service is $5 per month in the US for a minimum of 10 desktops, plus all the compute, storage, and network consumption charges for running your desktop. So once your pool is created and once a user starts a desktop, you will then start utilizing that compute shape, and then you start incurring the cost for the compute, for the storage, networking, etc. Now we can use virtual machines or dedicated virtual hosts or DVH. The default setting for Windows desktops is DVH, but you can simply change that to by tagging the image so that you can use a VM, a virtual machine for Microsoft Windows, provided that your license agreement allows you to use virtual machines in OCI. And we support today AMD and Intel-based shapes. So in conclusion, here's our summary. OCI Secure Desktops allows you to create virtual desktop infrastructure seamlessly integrated into OCI services. Less than 5 minutes, once you have done the setup, you can create desktop pools from a single centralized management. There's no bundling requirement, which means that you can set up the Linux or Windows image that you desire, and you can pick and choose which shapes inside OCI you're going to use, provided they are supported with that OS image. And Secure Desktops use its own VDI protocol plus HTTPS, as Jan was mentioning, which means that we don't have multiple protocols or third-party technology involved, and that simplifies our security and the overall setup. And we designed the service with a zero trust, security-first architecture, just like all the services inside OCI. I have a few links here for you to see the documentation, see our blog for announcing the service. We have a number of videos, so you can see an overview, see how to set up your tenancy, and then look at the client view and the administrator workflow. It is similar to what you've seen at the demos today, but then you can at any time just take a look at each one of these separate videos. And if you've been to Oracle Cloud World 2023, you can also have a recording of this presentation that was done, and a recording of this webinars are also going to be available. So there are many ways for you to review this information again, or to provide information to your colleagues to learn more about Oracle Secure Desktops service. With that, I'll leave you with information, so how you can reach us. Feel free to contact us if you'd like more information about the service, who would like to have more details about it, and so on. And with that, thank you very much. We're going to turn it over to Zaid.
Thank you, Renato. We greatly appreciate your time, and a special thank you to Renato, Jan, Joost, and Vijay for this presentation and demo. And if you have any questions afterwards, please feel free to join us on the OCI forum and continue discussions there. We hope to see you next time, and thanks for attending.